On November 15, 2017, a catastrophic flash flood swept through Mandra, Greece, causing widespread destruction and tragically taking 24 lives. The immense power of the water, reaching 4 meters high in some places, didn't just flood a town, it reshaped the very landscape. But how can we understand the true force of such an event to prevent future disasters? The answer, surprisingly, might be found by looking at the aftermath from above. While initial studies focused on the damage in urban areas, a deeper look into the mountains upstream revealed incredible geological changes. This is where our story begins, at a place called the Katsimidi alluvial fan, a landform created by ancient floods. The 2017 flood reactivated this dormant giant, tearing through it with a powerful debris flow. Boulders bigger than a meter across were ripped from the earth and carried over 250 meters downstream. To map this incredible event in detail, we turned to modern technology. A drone, specifically a DJI Phantom 4 Pro. We flew at 90 meters above the fan, capturing hundreds of high-resolution images using specialized software like Pix4D and ArcMap. We stitched these images together to create an ultra-detailed 3D model of the area. We're talking about a resolution so fine, we can see features on the ground smaller than 5 centimeters. This digital recreation of the disaster scene gave us a virtual laboratory. We could see exactly where the flood eroded the land and where it deposited rocks and sediment. The 3D model showed a clear pattern. The largest boulders were dropped near the top of the fan, and the sediment got progressively smaller as the water spread out. We even saw how a forested area acted as a natural barrier, trapping much of the coarse debris and preventing it from choking the main stream. By tracing these erosion and deposition patterns, we can reconstruct the flood's dynamics, how the water and debris flowed, how powerful it was, and how it behaved. This is more than just an academic exercise. This drone-based approach allows us to quickly and safely map disaster zones, preserving crucial data that might otherwise be lost to cleanup efforts or another weather event. Understanding these processes helps us assess hazards more accurately. By seeing how an ancient landform was reactivated, we learn valuable lessons about where it is and isn't safe to build. Technology like this empowers us to turn tragedy into knowledge, helping communities become more resilient in the face of extreme weather. Thanks for watching, and if you found this interesting, please like and subscribe for more content.